Hello and welcome to Gaffey's Grinds. My name is Jesse Gaffey and I am a science teacher trying to help you guys understand a little bit more about junior cycle science. So in these videos, we'll be taking difficult concepts from the course. We'll be trying to break them down into small manageable pieces and giving you opportunity to practice and master the content before you move on to the next stage. I do always ask for a few things. This is a brand new series that we're doing here on energy. So this is a good place to start. You should always start on video 1 of a playlist, because if you don't, it's going to be more difficult to understand video 2 and video 3. I always ask for a few things, and that is that you give the video your full attention while you're watching. So you should eliminate any distractions now by closing any open tabs that you have open, closing down your social media tabs, and just giving this video 100% focus. The other thing is I'm going to be asking you to do some tasks, to write some things down, to do some practice while we go through the videos. And it's really important that you do those tasks. If you don't, then you're really not going to learn very much. And I'm guessing if you're here watching the videos, it's because you want to learn. So if you want to absolutely make the most out of these videos, you need to do the tasks and the questions when I ask you to. I'll try not to ask you to do anything I don't think you're able to. I'll only ask you to do stuff that I've explained properly. And again, if you do the stuff, I promise you will get really good. You will learn a lot of stuff. You will get really good at science. And if you don't, then you won't. So you're wasting your time. Okay. All right. So today we are starting a topic on energy. Now, energy is honestly, it's one of the most difficult topics to teach. And it's because it's quite difficult to easily describe and easily define what energy is. Now, in these videos, I am going to be using some very simplified explanations and definitions of energy and how energy is involved with different objects and stuff. I'm going to try and make it as simple as I can, but it's so difficult to describe and define what energy is that a lot of textbooks, for example, don't even try to do it. So I'm just going to try and make it as simple as I can. Now, energy is incredibly important. It's really important that we talk about this topic because it's involved in not just so much of science, but in so much of life in general. It's involved in everything that happens. So what is energy? Really simply, energy is what makes things happen. So anytime something happens, even like small things, energy is involved. Okay, so energy is what makes things happen. Now, how exactly energy makes things happen, that's going to be the topic of the next couple of lessons. What do I mean by make things happen? I mean, like if something makes a sound, if something heats up, changes temperature, something cools down, if something lights up, something glows, something falls over, something falls off the table, someone bangs their head, somebody goes for a run, somebody eats food, a chemical reaction happens. All of these things involve energy. Everything involves energy. You turn your PlayStation on, it involves energy. You turn your TV on, you turn your light bulbs on at home, you go for a drive in your car, you burn some coal. All of this involves energy. So it's literally related to absolutely everything around you, everything you do in life. Now, we're going to be learning about two main terms or words when it comes to energy. And those two terms are energy stores and energy transfers. So this first video today is going to be about energy stores. Now, when we talk about energy stores, we talk about, say, you could take an object, any object, and you look at what's happening around that object, and you talk about the energy that an object has in terms of an energy store, okay, or different energy stores. So you use energy stores as a way of trying to explain what exactly is happening to an object. So take any object, look at the things happening in it, around it, and you can explain it in terms of energy stores. An energy store really is just how energy is linked to an object. So when we talk about an object like, I don't know, a cup of coffee, we can talk about how any energy is linked to it by talking about an energy store. So with that in mind, we're going to talk about the first energy store. So imagine we have some water. Okay, so we have some water. And it's just been sitting out on the table for about an hour in a cup or a glass. We have some water. Now, because it's been sitting on a table for like an hour or so, it's had time to adjust and come to room temperature. So it's the temperature that it is in the room. What is that temperature? Well, room temperature is around 21 degrees Celsius. We take that water and we pour it into a pan and we heat it up. What happens is the temperature of the water increases. So now we've got water that's at 50 degrees. We say that we had to add energy to the water to make its temperature go up. So we can talk about something called an energy store. And this first energy store is called the thermal energy store. The thermal energy store. And the thermal energy store is where we have energy involved in changing temperature. So just like here, we have the water going from 21 degrees up to 50 degrees. We talk about energy in the thermal energy store of the water. And we can represent it by just drawing a box like this. So in the beginning, we say that the water was at 21 degrees. We can represent this little box as showing how much energy was in the water. So we say the thermal energy store of the water had some energy in it when it was at 21 degrees. It's not empty because it's still got some energy. It's still at 21 degrees. It could have been colder than that. It could have been 5 degrees. It could have been minus 20 degrees. Those would have been even lower temperatures and the thermal energy store would have been even less full. So there's still some energy in there. But by taking our water and heating it up, to get the temperature to go up, we had to add energy to the thermal energy store. So now the water has more energy in the thermal energy store. Now, it's really important, guys. I want you to listen while I'm writing and not be trying to take down everything. Listen to the explanations, not be trying to take everything down. Okay. When we talk about energy involved in a change in temperature, this is the thermal energy store. Thermal energy store. Okay, so it's energy involved in a change in temperature. So that's the first energy store, the thermal energy store. We'll take a look at another energy store now. So say we have a car. And the car is going slow. It's moving slow. And whoever's driving decides that they want to make the car go fast. So they push down the pedal, accelerator pedal, and that makes the car go faster. Well, something has happened. The car has gone from moving slow to moving fast. So something happened. So energy is involved. And we say that energy has been added to an energy store. Now, it's not the thermal energy store because we're not really interested in the temperature of the car here. What we're interested in is how fast the car is moving. When we talk about the kinetic energy store, kinetic. So kinetic, this word, kinetic, means moving, movement. So kinetic means movement. So kinetic energy store is energy involved in movement. Now, when the car is going slow, we can again represent it by just drawing a box. When the car is going slow, there's a small amount of energy in it. Again, it's not empty because the car is still moving. So there's some energy in there. But when we push the pedal and we make the car go faster, we have added energy to the kinetic energy store. So now, the kinetic energy store has more energy in it. We've added energy to the kinetic energy store. That is the second energy store. Let's have a look at another one. So here, I have a table. And on that table, I have a book. And what I'm going to do is I'm going to take the book, and beside the table, there is a wall. And on the wall, there is a shelf. And I'm going to take the book and I'm going to lift it up. And I'm going to put the book on the shelf. So something has happened to the book. It has been lifted off the table. And it has been placed up higher. So I have lifted the book. In this case, we talk about something called the gravitational energy store. Gravitational energy store. And when the book is on the table, again, I'll draw the box to show gravitational energy store, there is some energy in here. Like, it's not empty because it's already lifted off the floor. It's not on the floor is down here. So if it was on the floor, it would have a lower amount of energy because it's not up as high. So it's still got some energy. But when we lift it up, by lifting it up, we add energy to the gravitational energy store. So it now has more energy because we have added energy to it. Okay, so gravitational energy store is the third energy store. Okay, what we're going to do at this point is we're going to stop. And what I want you guys to do is, from memory now, we're going to start making on your page a little mind map. I'm going to put energy stores in the middle. And what you guys are going to do is you are going to use arrows to bring it out from the middle. And so far, we have looked at 3 energy stores. So if you can, I would like you now to write down the names of the 3 energy stores we've looked at so far. Now, without looking back, okay? So trying to do this from memory as best you can. So pause the video and do that now. This is what you should have had. You should only be watching the video now. You should only be listening again. It's really important that you do these tasks. Otherwise, you're not going to learn anything. It's really important. So when I ask you to pause, you should pause the video and do the task and then play again to hear the answers and then correct. So you should now have a correcting pen. You should make sure you have it right. If you don't have it right, if it's correct, you need to tick it. If it's not correct, then you need to cross it out and fix it up. So using a different color pen, I like red, but if you don't have red, green or purple is fine. So energy stores, we have so far the thermal energy store. Excellent. We have the kinetic energy store. And the last one we did there was the gravitational energy store. Excellent. Now, if you can, to take it to the next level, can you tell me what each of these is? Or when we talk about them. So energy involved with or in. So energy involved with. Okay, well, I'm going to do this first one for you, and then you're going to do the other 2. So this is energy involved with a change in temperature. So basically, anytime there's a change in temperature, we're saying energy has moved in or out of the thermal energy store. So energy has been added or lost from a thermal energy store. You try the other 2 now for me. Pause the video and do it now. Okay, so it should start, just so I'm clear, it should start with the same phrase, energy involved in or with. Okay, so and this should also be energy involved when, maybe. I'll start that one for you. Okay, so pause the video and try and finish those now. Okay, so hopefully you said energy, the kinetic energy store is energy involved in, well, it's movement. So whenever an object moves, we say the kinetic energy store is involved. Energy is being added to the kinetic energy store to make it move or to make it go faster. To make it go slower, then energy would be leaving or lost from the kinetic energy store. Gravitational energy store is energy involved when, well, what happened to the book? Think about what happened to the book in the example. So if you didn't think about that, pause the video and think about the book. Okay, so it should be energy involved when an object is lifted. Well done if you said that. If not, you need to fix it now. Okay, all right. Again, if you wanted to take this to even a higher level, you could give me an example of each one. So example, the book from table to shelf. An example, and you could do the other two. Okay, pause the video and do those examples now. Good, okay, we're going to move on. We're going to take a look at a fourth store. All right, so imagine we have a battery. Okay, our battery is full. So it's a new battery. We just opened the pack and we took it out. And we put the battery into a device like a torch maybe. And we use the torch for a couple of hours. And then we have our battery that is now dead. Dead battery, or it's flat. It's a flat battery. These are terms we use to describe a full battery like a new one, and a dead battery is one that we've used up all the energy from. When we're talking about a battery, we talk about chemical energy store. Okay, the chemical energy store. So when we have our full battery, we have this chemical energy store which is completely packed full of energy, full to the brim. It's a brand new battery, it's packed full of energy, the chemical energy store. What this basically means is it's got loads of chemical inside the battery that's ready to do chemical reactions, and that will release the energy to be used. When the battery is dead, you've used it all up, you've used up all the energy, the chemicals inside the battery aren't able to react anymore and release more energy. So what we say is now the dead or the flat battery doesn't have any energy left in its chemical energy store. That's a battery. The chemical energy store is also important when we talk about things like food. So for example, we would have different types of food like say bread or pasta. And then we have, if we compare say bread or pasta to say some peppers. Both of these are tasty foods. I love both. I love lots of different kinds of bread, croissants and toast, French toast, a nice chicken fillet roll, lots of different forms of bread, but peppers are also really nice in pasta dishes and on pizzas. But we eat them for different reasons. And the bread, we'd say we eat more as bread belongs to a food group called the carbohydrates. And these are foods that we eat because they contain a lot of energy. So we would say that bread would have a lot of energy stored in its chemical energy store. So we eat bread for energy. Peppers also have some energy in the chemical energy store, but it's much, much lower. So just eating peppers all day wouldn't be very good for getting enough energy to stay, for your body to keep functioning all day. And we do get other things from peppers, things like vitamins and minerals, and they're the main things, vitamins and minerals, and they taste good, obviously, but not so much do they have energy. So bread, pasta, rice, potatoes. These are all carbohydrates. And they contain chemicals that have a lot of chemical energy or energy in the chemical energy store. And whenever we talk about our bodies moving, so we obviously eat food, and then we talk about our bodies moving, particularly we talk about our muscles moving. Well, all of this is related to the chemical energy store, because when we eat food, energy from there transfers into the chemical energy stores in our muscles. So we eat food and we get this sugar inside the food called glucose. When our body breaks down the food, we get this sugar called glucose. Glucose has a lot of energy in its chemical energy store. And our body, what part of our cells then are responsible? We've just done this in our previous topic. What part of our cells are responsible for releasing that energy into the cells? So on 3, 1, 2, 3. Okay, so I'm hoping, like you said, the mitochondria. So the mitochondria are able to take the glucose from our food, from our bread, for example, and able to break it down and release the energy that's inside in the chemical energy store of the food. Another thing that's important is when we talk about the chemical energy store is when we have chemical reactions that make the area around them hotter or colder. So things like taking a piece of wood or some gas in a Bunsen burner, for example. But if we take a piece of wood or coal and we burn it at home, then we transfer heat to the surroundings. We talk about these substances as fuels. Coal and gas and wood are fuels. And these are, again, chemicals with a lot of energy in the chemical energy store. The chemical store is important for batteries, food, and fuels. So fuel is a substance or a chemical with a lot of energy in its chemical energy store. And when you burn it, you can release that energy to the surroundings. So that is number 4, the chemical energy store. All right, we're going to take a look at the 5th energy store now. And that is related to, so imagine you have an elastic band. And the elastic band is just loose. So the way, if you take it out of the packet, it's just loose. It's not tight. It's not stretched tight. We say that it's loose. Now you take that elastic band and you stretch it. You stretch it out and you hold it stretched. So this is the elastic band. It's now stretched. Something has happened to it. You have stretched it. You have done something to it. So energy is involved. So again, an energy store is going to be involved. Now it's not the chemical energy store and it's not the thermal energy store because there's no change in temperature. It is what we call the elastic energy store. Elastic energy store. And we see the elastic energy store not just in elastic bands that we stretch, but also springs that we can stretch when we stretch a spring, or we can also squeeze a spring. We call this compressing. When we compress a spring, or we stretch a spring, or we stretch an elastic band, we talk about the elastic energy store. So when the elastic band is loose, there is just a small amount of energy in the elastic energy store. And when we take the elastic band and we stretch it, then what we have done, sorry, that shouldn't be way bigger, they should be the same size. What we have done is we have added energy to the elastic energy store, like that. Okay, what we're going to do is we're going to scroll up and you're going to add for me the next 2 energy stores. Okay, so pause the video and add the next 2 energy stores. Okay, this is what you should have. You should have number 4 was the chemical energy store. And number 4 was the elastic energy store. That's number 5, sorry, elastic energy store. Well done. If you got those 2 right, excellent, good job. So you should tick them to show so that you know that they're correct. Tick them. And then if you can, explain what each of them is. So the same way we did the other ones, it should start like this. Energy involved. Energy involved. And obviously the elastic energy store is involved. You start it the same way. Okay, pause the video, try and explain what they are. Okay, the chemical energy store is energy involved with chemicals. Example, in batteries, food. Now, I know we don't always think of food as chemicals, but food is a chemical. It's made up of the same stuff that any other substance is made up of. So it is a chemical. They're just chemicals that we can eat. Chemicals that we have found out that are safe to eat, and that they give us energy, and they give us the things that we need, like vitamins and minerals, and fats and proteins. But they are still chemicals. They're made of the same substance, the same atoms, the same elements as all the chemicals that we don't eat, like limestone, for example. Limestone is made of some minerals that we actually do eat as well. So, it's not, they are just chemicals, but we do call them food as a group. So we've got batteries, food, and what was the other one again? Oh yeah, fuels. Energy involved in chemicals. And the elastic store was energy involved with an object. And what do you do to the object? So think of the elastic band and the spring that we talked about. What are we doing to them? Pause the video, make sure you have an answer attempted. Okay, so it's energy involved with an object that is stretched. Well, I don't know if you use the word stretched, or what's the opposite of stretched? Squeezing together. What word did we use for that? Okay, stretched or compressed. Good, well done if you have that right. Good stuff. All right, now, there are 3 more energy stores, which we're going to talk about. I'm just going to talk about them briefly. We're not going to focus on them. We're going to focus on those first 5. But there are 3 other ones, which I'm just going to mention, okay? We have something called the nuclear energy store, which has got to do with the energy stored inside an atom. So when we study a little bit more detail about what's inside an atom later, we'll talk about energy that's inside the atom. And it becomes important when we talk about things like nuclear bombs or like nuclear energy. So getting electricity from nuclear sources. So that's what we're talking about, the nuclear energy store. We also have the magnetic energy store. Magnetic energy store. And this is energy involved in like the 2 magnets when they come close to each other and they get pulled towards it or they get pushed away by the magnet. That's what we're talking about, the magnetic energy store. And the last one is what we call the electrostatic energy store. And this is probably the most difficult one to explain, but it's got to do with charged particles. So particles that have a charge and how they are attracted, or they attract or they push away other particles that have a charge. Now, we're not really just not going to focus on them for the moment. Later on in school, you will deal with these when you do future sciences, like when you go into Leaving Cert and do physics or chemistry, you would talk about these types of charges a little bit more. But for now, the other 5 are the ones we're going to focus on. It's not because they're more important, it's just they're the ones that are easiest to understand for us at the moment, okay? So what I will get us to do is add them into your mind map now, just the names. You don't have to explain what they are. So nuclear, magnetic, and electrostatic. Add those 3 to your mind map. Right, so again, you should only be watching again. So you should have paused the video. You should only be watching again if you've added those 3 to your mind map. I just want to deal with one thing that sometimes students get confused with. And that is, it's really important to understand that most objects will have more than one energy store. at any one time. We might talk about just one store because we just want to focus on that one store, but most objects will have more than one energy store. If we take, for example, here's a man, and the man is standing still. He's stationary. Stationary means he's not moving. And the man decides he's going to go for a run. So the man is gone for a run. So now he is running. Now the man went from not moving to moving. So obviously there's an energy store involved in here. Something has happened. There's an energy store involved. We would talk about the kinetic energy store. And we would say that when the man is not moving, the kinetic energy store is pretty much empty. Now it's not completely empty. Like he's still going to be blinking. He's still going to be making very slight movements, but he's not going to be actually actively running. So he's not got much energy in his kinetic energy store. And after he goes running, as he's moving, there's obviously energy being added to the kinetic energy store. We also know from our own experiences that if the man stays running for like 20 minutes, we're going to have another energy store involved. That would be the thermal energy store. So imagine yourself going for a run. In the beginning, it's a cold day. You might be quite cool. So you don't have much energy in your thermal energy store. And after you've been running for 20 minutes, your thermal energy store has started to get more full. Energy has been added to your thermal energy store. And now you feel hotter. Okay, now, obviously, there are two energy stores involved in this action, this man going running. But it depends what the question. If we were talking about, well, which energy store is filling up when a man goes running, we're probably most interested in this one because we're talking about running. We understand that we're talking about the man's going moving. So the movement is the key thing. So even though he also is going to get hot, so technically, yes, the thermal energy store is also involved, we're probably most interested in the kinetic energy store. But that doesn't mean that we pretend that this one doesn't exist. It's just not in our focus for a particular question. All right, it's time to do some practice now. Okay, so what I have here is I have for you guys a 9 pictures here. Okay, I'm hoping you can make out what they all are. Sometimes people are confused about this one. This is a chocolate bar. Okay, just if it's not clear what it is. What I want you to do is I want you to pause the video in a minute. I'm going to ask you to pause the video and I want you to tell me what energy store or stores are involved with each of these things. Okay, now I'm talking really about the main energy stores, but if you know that there are some other ones, then you could also talk about those. So there's probably more than one for all of the pictures, but there's going to be a main one. Okay, so I want you to pause the video and write down the energy stores involved with each picture. Do that now, please. Okay, so you should only be watching the video if you have done for the 9 pictures the different energy stores involved. Okay. All right, we've got a car here, and it's obviously the lines here show that the car is moving. So this probably shows the car is actually moving. So racing cars probably going pretty quick. So the energy store involved here, the main energy store we're interested in is the kinetic energy store. Now, those of you who are really on the ball and thinking will probably know here that the chemical energy store would also be there because there's fuel in this car. It's petrol that makes it move. So fuel, petrol is a fuel. So the chemical energy store would be an energy store here as well. There would be energy in there. So you should also mention that. And if you drive the car for a few minutes, what's going to happen to the engine is the engine's going to get hot. So it's going to also add energy to the thermal energy store. Okay, now we're not really interested in what's going on in the thermal energy store here, but I suppose we can include it anyway. Number 2 is a slingshot or a catapult. And it works by pulling back the elastic bands, the catapult. So the main energy store we're interested in here is the elastic energy store. So well done if you said that, elastic energy store. Now, I suppose when you let go and fire the stone or whatever's in it, then you're also going to have the kinetic energy store of the moving object, whether it's a stone or whatever you're firing from the catapult. But the most important one there is the elastic energy store. This one here is a parachute. So this obviously is going to start with somebody up high and falling down with the parachute. So we would talk about the gravitational energy store, because they will be starting up high and they will be falling down. So in the beginning, they are lifted up high and then they fall down as their height from the ground decreases. The energy in the gravitational energy store would get lower and lower. These strings here will probably be a little bit elastic. They will probably be able to stretch a tiny little bit. So some people, I remember we've done this before, and some people said the elastic energy store, and you're probably right. And also as they move, as they fall, would be the kinetic energy store. So you should have those three, but the circle, the main one is the gravitational energy store. You should probably put a circle around the main one for each one. So gravitational energy store is the main one. Maybe elastic, you might have said, and you probably said kinetic. So those are correct there. The next one, this is burning wood. Okay, so hopefully you realize that it's burning wood. It's a fire. So wood is a fuel. So that is going to mean we've got the chemical energy store, because we've got fuel. And obviously, if it's a fire, then it's going to heat up the surroundings. So we would also have the thermal energy store. Energy would be get transferred or sent into the environment. We talk about the thermal energy store. Rubbing hands together. We would do this if we were really cold. We rub our hands together to try and make them warmer, to warm ourselves up. So obviously, if you think about it, we're moving our hands to warm ourselves up. So what stores are involved there? Well, the movement is going to be the kinetic store. So that's probably the main one. You can circle that one, kinetic store. But also the friction between our hands is creating or is making them warmer. So the temperature of them is going up. So that's going to involve the thermal energy store. Well done. If you said those two, those are the two main ones there. The next one is a pogo stick. Tigger is on a pogo stick. So he's bouncing along. So what stores are going to be involved here? Well, the main one I would say is of the spring. As the spring hits the ground, so as the spring hits the ground, we've got the spring like this. And as it hits the ground and Tigger's weight is on top of it, pushes it down, the spring gets shorter. And then it's going to bounce back up. So the spring gets compressed. So what energy store is involved in that? Okay, I'm hoping that you said the elastic energy store. So the elastic energy store is going to be here. But Tigger is also going to be bouncing up and down. So we would also have the gravitational energy store, because he's being lifted off the ground or pushed off the ground. And he's moving. So we've also got the kinetic energy store. So well done if you've got those. But I would say the main one is the elastic energy store. And then we have the kinetic and the gravitational. This here is an electric heater. Electric heater. Now, really importantly, you remember from the energy stores, I did not say that there was such thing as an electrical energy store. That is not a thing, an electrical energy store. That is a very common mistake students make. There is no such thing as an electrical energy store. I'll just make that clear. So the main energy store that we're interested in here would be the thermal energy store. So the radiator gets hot. Let me say the thermal energy store. We add energy to the thermal energy store of the radiator when it gets hot. The chocolate bar, well, this is food. So this would be the chemical energy store. Well done, if you got that right. The chemical energy store is the main one there. And then we've got a rocket. Okay, so we've got a couple of things going on here. Obviously, we've got it lifting off the ground. So as it lifts off the ground, it's going to have energy added to its gravitational energy store. It's moving. It's got movement. As it moves, it's got kinetic energy in its kinetic energy store. So we've got kinetic and gravitational. It's also got this big combustion or fire going on at the back of it. So this is burning. So what would be burning? Well, anytime you burn something, we're burning a chemical called a fuel. So what type of energy store would this be? Okay, this would be the chemical energy store. So you should have that. And I suppose it's also getting hot. So the temperature of the area around the rocket's going to go up. We talk about the thermal energy store. So there's a lot involved in a rocket. Got the gravitational, kinetic, chemical, and thermal. All right, so hopefully you did pretty good on those. What I want you to do now is for each of the 5 main energy stores, write down 2 objects which can be involved with those stores. So for each of the 5 main energy stores, write down 2 objects which can be involved. So I'm going to show you how I would do the first one. So we've got the thermal energy store. Thermal energy store. And I'm going to talk about 2 objects that could be involved in the thermal energy store. 2 objects. So we could have a cup of coffee. Okay, so cup of coffee. When you make it first, it's got a lot of energy in its thermal store. If I forget about it and leave it on the table for half an hour and then go, oh, damn, I forgot to drink my coffee, there is now going to be less energy in the thermal energy store. A second one could be a bowl of porridge. Porridge, I think that's how you spell porridge. Bowl of porridge. Again, when I first make it, it's got a lot of energy in its thermal energy store. And if I don't eat it quick enough, by the time I finish eating, it's going to be cold. So it's going to have less energy in its thermal energy store. Okay, so I want you to pause the video and do the rest. Okay. So you might have said, so the second one then was kinetic. You could have said something like a ball. When we kick a ball, it has energy in its thermal energy store. When we kick it and go for a point, or we're playing hurling and we hit a ball with the bat or with the hurl. If you like snooker and you hit the balls on the snooker table or pool. If you throw darts, so all of those things. Also then cars, planes, boats, anything that moves, runners, athletes, all of those things, kinetic energy store. The next one was elastic. Actually, I don't know if that was the next one, but no, the next one was gravitational. Doesn't matter if you do them in the same order or not. Gravitational. So things like planes, when planes are flying. What else do we have? Planes, stuff that would fall down from the air. A ball kicked up in the air, for example. You could have an apple falling from the tree. You could have a bird, a bird pooping on you, for example. You know the way they say if a bird poops on you, it's good luck. I don't know about that, but the fact that it falls down means it had gravitational energy, or energy in its gravitational store, and it fell down. It didn't have it anymore. The rocket, obviously, as it went up, was one of our examples. The other 2 then are chemical and elastic. Chemical and elastic. Hopefully you've already done these. If you haven't done these now, like I said, you should have already paused ages back and done these. You should, if you were struggling to learn how to do those, you should be able to at least do these last 2 now. Okay, so chemical are things like batteries, food, and fuels. Batteries, food, and fuels. So examples of food that would be bread, pasta, rice, potatoes, all your carbohydrates would have a lot of energy in the chemical energy store. And fuels, things like coal, gas, wood, turf, all of those things would have energy in the chemical energy store. And elastic would then be things like elastic bands or springs. What else would we have? Guitar string, for example, would be quite stretched. So when you tune it up, you stretch it, and then when you pluck it, it vibrates up and down. It would have energy in its elastic energy store. What else? That's pretty much it covered. So hopefully you got on okay with those. That's the end of this video. We have learned about the 5 main energy stores, and we have practiced applying our information. So if you found today's video useful and you found it pretty easy to follow, do give us a like, guys, and I'll see you in the next video when we talk about energy transfer.